In this video, we want to find the exact solution to each of these exponential equations. So we've done some where you have a single base on one side, something like, say, 7 to the x is equal to 8. And we simply took the log of both sides to any base. Normally it would be base 10 or natural log. Take the log of both sides, solve for x. But this one's a little bit different. So when you have something like this, where you bring this 3 to the other side, like this one over here, you have 3 terms. A lot of times it's going to be a quadratic equation, or an equation that can be written in quadratic form. So we're looking at something like this. If you have an equation in this form, ax squared plus bx plus c equal to 0, where a represents a coefficient of the squared term, b is a coefficient of the linear term x, and c is the other constant, or is the constant, then you just plug into this formula and simplify. Now, since it wants the exact answer, we're not going to use a calculator. That's not for the main answer. So let's do this. We'll rewrite this. What I'm going to do first is multiply both sides by, got 4 to the x here, 4 to the negative x here. Don't like to deal with negative powers here, so let's multiply by 4 to the x. So this will be 4 to the x times 4 to the x. Bases are the same, so I can write this as 4. X plus x is 2x, and then 4 to the x times the second term on the left over here. 4 to the minus x and 4 to the x is 4 to the 0, which is 1. 1 times negative 10 is negative 10, so that's going to stay negative 10. And then on the right side, multiplying by 4 to the x will give me 3 times 4 to the x. Now you don't want to say 3 times 4 is 12, because this one's to the x power and this one is not. So what we can do is I'm going to rewrite this in this form. 4 to the 2x, I can write that as 4 to the x, and then put parentheses here, and that's to the second power. Because when you have a power to a power, you multiply the exponent as 2 times x, does give me 4 to the 2x, and then bring this over, changes the sign to minus 3, that's times 4 to the x. And then I have a minus 10. So then the right side is going to be 0, because I added the negative 3, 4 to the x to both sides to cancel it. Now, if I replace this 4 to the x by a y, and a y here on this one, this comes out to y squared minus 3y minus 10. So that's a quadratic equation in the variable y. But I'm just going to leave it the way it is. You can make that substitution, solve for y, and then replace the y by 4 to the x, and then continue to solve. But what I'm going to do is this. I'm just going to say this is a quadratic in 4 to the x. So let's try to factor this out. 4 to the x and 4 to the x. So all I'm doing here is saying that 4 to the x quantity squared has those two factors. And then I want to find factors of minus 10 that'll come out with this middle term. And that should be a minus 5 and a plus 2. And this will still be equal to 0. So you can check it. 4 to the x times 4 to the x is 4 to the 2x, which is the same thing as this quantity here. Then minus 5 times 4 to the x, and at 2 times 4 to the x, add them up, that gives you minus 3 to the 4x. That checks right there. And 2 times minus 5 is minus 10. Then we set each factor equal to 0. So this factor should be equal to 0. The only way that the product of two factors is 0 is if one factor is 0, or the other factor is 0, or if they're both 0. So we set these equal to 0. And then we solve for 4 to the x. So adding 5 to both sides, for that first one I get 4 to the x is equal to 5. Now for this one, if I have 4 to the x plus 2 equals 0, bringing the 2 over gives me 4 to the x is equal to negative 2. So this breaks down into 2 exponential equations. 4 to the x equal to 5, and 4 to the x equal to negative 2. Now I want you to keep in mind that anytime you have a positive base, anytime you have a positive base taken to any power, it doesn't matter whether the power is negative or positive or 0, that number is never going to equal to a negative. It's always positive. So this equation here has no solution, no real solution at all. This one does. So I want to solve for x. Now, since I want an exact solution, I can just go ahead and take the log of both sides here. I have two positive numbers. I can do that as long as both numbers are positive. So what I'm going to do is I'm going to take the log to base 4 of both sides. And then this side, I have the log to base 4 of 5. Now the reason I selected base 4 here is because it simplifies easier. Notice the log of 4 to the x to base 4 is simply asking 4 to what power gives me 4 to the x? Well, that's just x. So the left side simplifies to x, and the right side stays natural log of 5 to base 4. It wants the exact answer, so this is an exact answer. Now, what if they wanted an approximation? This is the answer for this one, but just to carry it another step here, what if they wanted an approximation, say to 3 places? Then you would use your calculator, and since I use base 4, I'd have to use a change of base formula. So you would simply say, well, okay, this would be the same thing as changing the base to natural log. I could use base 10, but your calculator has natural log also, so either one's going to work. I would have the natural log of 5 over the natural log of 4. Then you can just use a regular calculator there. And this should come out to 3 places. Run it out to 3 places, 1.161. Okay, I'm just giving you an option. Here we wanted the exact answer. So they could have said no calculator. So you could get the answer without using a graphing calculator or any kind of calculator. This is the exact answer here. Now I could have used another base here. So no, let's look at this. This is your answer here, the simplest answer you could give. But I could have done all this also. I could have said, well, let's take the natural log of 4 to the x. Both sides, natural log. Obviously, the other one still has no solution. So we're just dealing with this one, log of 5. And then here what I would do, okay, properties of logs allows me to take this exponent and make it into a coefficient. So this would be x in front. Natural log of 4 is equal to ln of 5. And then I would divide both sides here by ln of 4. ln of 4. These divide out. And I would get the same setup, ln of 5. So if you did this, then your exact answer would be this. Still the same. That's what we gave here. Just written in a different form, but if you compute the values, you're going to get the same thing, 1.161. Now this one, again, we're going to do the same sort of thing. We can't just isolate, want to move something to the other side and take the log of both sides. That's not going to work in this particular case. So what we're going to do is this. 16 is the same thing as 4 squared. And this is going to be x here. 4 squared is 16. And then to the x power gives me the original thing. And then on this one here, 4 to the x plus 1, that's the same thing as 4 to the x times 4. Because this is understood to be 1. So multiply powers of the same base, you bring down the base, that's 4 there. Add the exponents to x plus 1. We get that. So with that in mind, I'm just going to rewrite this. Say, okay, I can rewrite this equation then. Instead of writing it this way, what I'll do is I'm going to write it this way. 4 to the x quantity squared. Still the same thing as what I have here. Because by laws of exponents, power to a power multiply exponents, so 2 times x still gives me 4 to the 2x here, which is what this would be. and then this is a plus, and I'll write this as 4 times, and then this will be 4 to the x minus 3 is equal to 0. If I replace the 4 to the x by y again, this would be y squared plus 4, and this is 4x is y. This would be y squared plus, in other words, if I say y, let y equal to 4 to the x, then I would put a y right here. In the first parentheses, that would be y squared plus 4, replace the 4 to the x by y. So again, y squared plus 4y minus 3 equal to 0. So I would solve that equation for y. If it factors, I would use factoring. This one does not factor. This one does not factor. So if it doesn't factor, one option is to use the quadratic formula. I would use the quadratic formula, solve for y, and then where I have the y, I would replace it by 4 to the x. Because remember, I'm looking for x. That's why I just go ahead and leave it this way and say, okay, it doesn't factor, so I'm going to use the quadratic formula. So in this case, the variable is 4 to the x. So first I have to solve for 4 to the x using the quadratic formula. So 4 to the x is going to equal 2. So I just give you the formula a while ago. It's minus b. So this would be minus, and here the b is 4. So this is minus 4. And the formula is plus or minus the square root of b squared. Okay, b squared, that's the 4, so that's a 16 here. And then it's a minus 4 AC. A is the coefficient of the squared term. That would be over here, which is understood to be 1. So this will be 1. And C is the constant term right there. It's negative 3. And then under the denominator is 2 times A. A, the coefficient of the square term, is 1, so this will be a 1. And then I simplify this out. So this is going to equal to minus 4 plus or minus. So now under the radical, it's going to be 16 minus 4 times negative 3. So here, multiply this by negative 3 times the 1 times the negative 4. That's a plus 12. And 16. 12 and 16 is 28. That's over 2. And then we have to simplify this. So 28 is 4 times 7. So we can take the square root of 4. That'll become a 2 outside the radical. The 7 would stay. So let's rewrite this as minus 4 plus or minus. And then the square root of 4 is 2. That comes out of here. And then the 7 stays under the radical. Square root of 7 over 2. And then this is equal to, then here we can divide by 2. 2 goes into negative 4 and 2 goes into 2. So let's rewrite this up here as minus 2. 2 into negative 4, and then 2 into 2 is 1. So let's just leave it as a plus or minus 1, or just the square root of 7. So these are the two possible answers for 4 to the x. Okay, so what we have then, so if you use the y as a substitution, this would come out to y equals to negative 2 plus or minus the square root of 7. And then you just replace this by y, and you get your two answers. But in this case, so we have to say this then. We'll set it up this way. 4 to the x can equal to a minus 2 plus the square root of 7. Or 4 to the x can equal to minus 2 minus square root of 7. Now again, I told you, if you have a positive base to any power, that's always going to be positive. So note here I have a negative 2 and a minus the square root of 7. So this quantity on the right side is going to be negative. I can't have a negative equal to a positive, so this one has no solution. That one has no solution, so I have to reject that. So on this one here, the square root of 7, that is larger than a negative 2, and it's positive. So this is going to come out positive. So I do have an answer for this one. So I would take the log to both sides the same way I did it in the first problem, to base 4. So when I take the log of this side to base 4, like in the other one, that's just going to give me an x. Got the log again, because I have the log to base 4, 4 to the x. If this base and this base here, 4 are the same, then the log is simply the exponent, which is x. So taking the log of the left side to base 4 just gives me x, and on the right side I simply get the log to base 4. Put this in parentheses of -2 plus the square root of 7. Now I could have used another base. I could have used natural log, base c. I could have used base 10, and you'd get the answer. It would look different. It would look different, but it would be the same. This is the exact answer. And just like the first one, if you use the change of base formula, you would have the log, natural log of this quantity here, -2 plus radical 7, over the natural log of 4. So if you want it, or if they ask you for an approximation, then this would be negative point decimal 315. I'm just giving you this extra information just in case, but in this case, I want the exact answer. So this is what you'd have. And you can have other answers, okay? If they don't tell you what base to use, you could have other answers. This is the simplest one. Okay? Thanks for watching. We'll see you next time.